Good morning. Before I get into this, I want to acknowledge that there are a couple of other people that worked on the study with me. They are Joanne Elmer and Eleanor McAnch. They contributed quite a bit to the project. We also had a senior student from the University of Toronto that came in and ran probably the bulk of the microspecs that we used in analyzing for this study. Okay. And just that one. Okay, as an introduction, basically this study came up when we started to notice in a couple of papers that within the fiber analysis, people were incorporating the use of ultraviolet visible microspectrophotometry, and it generated a couple of questions. Would it be beneficial for us to incorporate this range, the ultraviolet range, within our fiber analysis, and should we do it on a routine basis? So that basically led to the study that I will be presenting today, where we looked at various aspects of the UV-Vis microspect to assess them, to evaluate its use within a forensic laboratory for routine fiber analysis. There were 4 factors that we looked at to determine whether it would be useful. The first one is instrumental stability, interference from mounting medias, interference from fiber polymers, and its relative value compared to visible microspectrophotometry. Just before I get into this, I'll indicate that we identified and confirmed all the fiber polymers, fiber types that we used within the study with FTIR. When I indicate the visible microspect, that the range that we cover is between 380 nanometers to 770 nanometers for this. For the ultraviolet visible microspect, the range that we measured started at 240 nanometers and went up to 770 nanometers. We started off looking at instrumental stability. We looked at same-day fiber analysis reproducibility. To do this, we took a green acrylic fiber, measured the absorbance 6 times in approximately the same location. The 6 measurements were taken over a period of 8 hours. Next, we looked at day-to-day fiber analysis reproducibility. Again, we used the green acrylic fiber. We measured the absorbance 6 times in approximately the same location. And we did the 6 measurements over a 28-day period. What we found for the same day, the spectral results were very consistent, as well as from the day-to-day, the spectral results also showed a consistency. So we felt that comfortable in proceeding on. The next step was looking at the interference that might occur with the mounting media that we used. So the UV-Vis absorbance was measured through glass slide, quartz slide, glycerin on quartz, and ZAM on quartz. This is the results that we obtained for the absorbance spectra for the different mounting medias. And it might be kind of hard to see. I know it's included in on the CD that you received. The results indicated that for the quartz slide and for the glycerin, there was no interference. However, with the glass, there's substantial absorption that occurred at 310 nanometers, and there was complete cutoff at 280 nanometers. For ZAM, there was substantial absorption that occurred at 290 nanometers, and there's complete cutoff at 265 nanometers. This was interesting for us to look at because who's ever done fiber analysis knows that you start off by mounting your trace, your control, on glass slides in ZAM. You do your identification and your comparison and your visible microspectrophotometry while it's mounted on glass. If we could extend it and go down to 300 nanometers and obtain additional information without on-mounting the fibers, that was interesting information for us to obtain. And it's something that you really do want to avoid. If anybody has had to on-mount fibers off of glass slides, it's laborious, it's time-consuming. There's a potential that you could damage the fiber. Also, there's a potential that you could lose the fibers as well. So it's something that we noted. Then we went on and looked at the interference from fiber polymers. We looked at the UV vis absorbance, and it was measured for white non-dyed fibers of different polymer types. And I've just listed out the various types of fibers that we've measured. We tried to do a range just to incorporate all the different types of fibers that we might come across within the forensic lab. The findings that we had, we grouped them into 3 groups. There's the ones that had a high UV absorbance below 300 nanometers, and included in this would be your protein fibers, which we included wool and silk, your polyester fibers, and we looked at PET and PCDT, and one acrylic fiber, and the acrylic that had MVP included in it as a copolymer. The next group was moderate to low ultraviolet absorbance below 300 nanometers, and included within this group is your acetates, which included your di and triacetates, your polyamides, which included your nylon 6 and 6,6, your monocrylics, and I won't go through what that includes, it's listed out already, and one acrylic, and it's the acrylic that had PVP included with it. The last group is where there was no ultraviolet absorbance or very, very low level of absorbance below 300 nanometers. And this included your cellulosic fibers, which be your cotton, urami, viscose. It also included olefins, and we tested both the polyethylene and polypropylene, as well as the acrylics, but it would be the acrylics without PVP and MVP. And just to give you an idea of what the spectra looked like that were generated within this part of the study, this represents the protein fibers, your silk and your wool fibers, and you notice that there is a high level of absorbance below the 300 nanometers. A very similar curve was produced by the polyester fibers. This is the polyamide fibers, your nylon 6 and 6,6. Again, you're looking at the fact that it has a low level of UV absorbance below 300 nanometers. Your cellulosic, we're getting really, really down there. It's low, very, very low to nil. I saved the acrylic, the monocrylic, and the olefin fibers to the end because what we found in running them, and you probably noticed when I did the summary, that there was acrylic fibers in each of the groups. What we found with the acrylics, monocrylics, and the olefin is that the copolymers had an impact on where they would land or what type of interference they would give us. It's something that I wanted to highlight and something that we needed to know before we proceeded on and looked at the colored fibers. And this is the example of the acrylics. You have some that are basically straight lines at the bottom, and then there's some that have a high or moderate absorbance. This is the monocrylics. And what we found within the monocrylics that there were some that actually gave us some peaks below 300 nanometers. and your olefin fibers at the end. Within the olefin fibers, what we found is that there was a few of them that gave us a number of peaks, but also too they gave us in different locations as well. Okay. Then we went on and looked at comparing the visible analysis with the UV-Vis analysis. What we did within this section is that we mounted the fibers on glass in ZAM. We ran them as we normally would run fibers when we do microspect, and we ran them between 380 to 770 nanometers. Then we turned around and still while they were mounted on glass, we ran them from 240 nanometers to 770 nanometers. Once we finished that, we unmounted the fibers and mounted them on a quartz slide using glycerin. And then we ran them again using the 240 to 770 nanometer range. We didn't run all the different fiber polymers that we tested earlier. We took a selection of them to cover high, medium, low, as well as the no UV absorbance range. What we tried to do here is cover a broad color selection. And the results that we got is that it didn't matter which way that we ran it, whether we ran it through just the visible or UV-Vis, whether it's on a quartz or glass. Within the normal visible range, we got the same peaks, the same shape, the same location. So there was no trend in sensitivity here. What we did find is that there was differences within that lower range. And we included wool fiber, even though it has a high absorbance, UV absorbance. We included it just to see what information, if any, we could gain from it. You'll notice that it has below the 300 nanometers a high peak, a very large peak, and this is very similar to the peak that was observed with the non-dyed white fiber. So we can conclude that this is from the polymer itself. But we noticed that within the range between 300 and 380 nanometers, there is an additional peak there that can be included in the discriminating power. Next, we're looking at a fiber that would fall within the moderate to low ultraviolet absorbance. Within this range, we noted that in looking at fibers that have a low absorption below 300 nanometers, that there was a little bit of a problem interpreting the spectra for the colored fibers. What we found is that it was a little bit difficult to know whether the absorbance that we were observing was from the fiber itself or whether it's from the fiber and the dye. So there was a little bit of caution that we had to incorporate when we looked at the spectra. We looked at the region between 300 and 380 nanometers, and we found that for the fibers that we ran, the colors that we ran, that there were peaks within this range. What we found with these fibers as well is to know whether we should unmount them in the future. We looked to see whether there was any indication of any activity below 300. And what we found is that if there was a peak below 300, then the spectra, when we measured it while it was mounted on glass, it was always greater than the spectra for the white fiber. And you'll notice that on the slide, the dotted line that's going across the bottom is a representation of the white diacetate, and the plain solid line as well as the long dashed line are the long dashed line is when the colored fiber was mounted on glass, and the solid one is when the colored fiber was mounted on quartz. Both of these are higher than the white fiber. The last group where there was no ultraviolet absorbance within this group would be your viscose fibers and the acetate fibers that we ran. What we found within this area is that there was a variation within the groups. What we found with the viscose fibers is that they would have peaks within the 300 to the 380 nanometer range, whereas the acrylic fiber did not have it for the colored fibers. Below 300, there were, in some cases, there would be peaks, and in other cases, these peaks would be indicated, but in some cases, the peaks would not be indicated. So that was of interest to us because normally we thought that there would be some indication, but in some of the fibers, there was no indication of a peak below the 300. And the example that I have up, the viscose fiber, demonstrates that. There is a peak in the range between 300 and 380, but as we move towards the 300 down to the 240, you'll notice that the long dashed line, which is the colored fiber on your glass slide, it tends to go down and peter out. However, when we turned around and measured it on the quartz slide, we found that the spectra actually goes up at that point. On the other hand, this is acrylic fiber, and you'll see that within the 300 to 380 nanometer range, there is no peaks within that range. However, there is an indication that something's going to happen below 300 nanometers, and when we ran it on the quartz slide, we found that yes, there was a peak there. Okay. And just to summarize what we had found, within the microspectrophotometry of all the colored fibers, they should be initially done with ZAM mounted on glass slides from 300 to 770 nanometers with the UV vis system. What we found is that there were additional peaks that could be obtained from the fibers in order to aid us in differentiating between trace fibers and control fibers, and that the range for 300 and 380 should be included. The need for remounting onto quartz slides for the full UV vis analysis, and that would be between 240 and 770 nanometers, depends on the fiber type and the spectral results. For fibers which have an increasing slope as it goes below the 300 nanometer point, need to be remounted in order to look to see whether there's a peak there. For fibers which have no increasing slope below the 300 nanometer point, they should be remounted. At this point in time, we don't know for sure whether there would or would not be a peak there. And for fibers which have polymers that have a high UV absorbance, no remounting is necessary. And we developed a little flow chart that sort of incorporates the conclusions that we came to, with the going down the left-hand side, that's the fibers that have the high UV absorbance below 300 nanometers, and that they should be analyzed from 300 to 770 nanometers. Once this is completed, you'd be done with the color analysis at this point. Going down the right-hand side includes fibers that have the moderate to low as well as the no UV absorbance. They should be analyzed with the range between 300 to 770 nanometers, and depending on what happens, what spectral results you get, you would continue on to on-mount them to analyze them for the full UV vis range, or you may decide not to, and then you'd be finished depending on what you received.